Hello everybody, my name is Dr. Justin Wagis. Hello everybody, my name is Dr. Justin Wagis. So for you, this time data warehousing and data mining will be handled by me. Okay, so I'm in the Department of Computer Science and Engineering and I'm a professor in the department. So my email ID, you can note it, okay, and you can contact me for any doubts. So when you talk about data mining and warehousing, the major course objectives which we need to satisfy are to understand the basic concepts of data warehouse. Okay. So why data warehouse is used and what are its use? All these things we will come to know in this after finishing this lecture. Of course, to learn the primary task of data mining processes. Okay. So what are the tasks we are going to do during data mining process? To know detail about the association rule mining and classification methods. So we'll come to know what is association rule. So association means normally, if you remember something, so we make some association between it. So, and of course the classification also we'll deal with. And finally, we should know the clustering algorithms. We need to know how to automatically cluster data according to its property, to study latest data mining applications in the final. So these are the course objectives. And finally, we have the course outcome as the CO1, which we call the course outcome 1, which is to realize data warehouse architecture and components of data warehouse. Okay, so this is the first CO1. And CO2 to perform pre-processing tasks of a data set. Okay, and formulate association rule and classify the data set, apply the clustering algorithm over a given data set, and finally to analyze various data mining applications. So these are the different course outcomes. Okay, so don't bother about these things now, but still keep it in mind. And of course, we have an assessment pattern. So for your CAA 1, the 75% of the thing will be in the basic level, that is the CO1, that we call it as K1, and 25% will be from CO1 in K2. Okay, so and for your CAA2, okay, everything will be from K2, and of course for your CAA3, it is divided and it is given in this format. Okay, so and final the end semester exam, this will be the pattern. So of course you are all aware of the evaluation criteria. So CAA 1, 2 and 3 will carry up to 30 marks of your internal marks, and of course your unit test and 2 will carry 10 marks. Assignments bar tutorial bar innovation work will carry 10 marks, and normally for me it is only assignments. The total internal and external marks finally come to 50. So totally total marks will be out of 100. So final exam marks will be 50 in semester marks. So total you will be having 100 marks. Correct? So anybody having doubt? We don't have any lab for this course. Okay. So let us now go for the syllabus to be covered. Okay. So and the right side which is shown is the your credit. So how many hours we are going to complete. So we have 3 modules that you already know. The first module will give you an introduction on data warehousing and mining, which includes why we go for data warehousing, and what are the data warehouse architecture commonly used, and what do you mean by multi-model data model, multi-dimensional especially. So which means you can view data in different dimensions, and of course online analytic processing technology, and it is categorization, and of course data cube computation. So these are the topics which will be covered in module 1. So this is the basic introduction module, and when we go for the module 2, it will go for data mining functionalities, and of course what are the major steps in data mining process, and of course the architecture of typical data mining system, and all these things will go. Okay, and then the important data mining steps like pre-processing. In that, we should know, we will study how the data being cleaned, which means the unwanted noise being eliminated, and how data from different sources are integrated to perform a common task. So what are the transformations we make, that also we will discuss. Okay, and of course the how to reduce the complexity, and of course discretization concept, hierarchies, and frequent item set mining. So which means, say for example, suppose you can, if you go to a supermarket, you can find that a person who is purchasing a normal ink, a pen, and then how likely he also purchase a ink. Okay, so this is called frequent item set mining. So that in that we'll study a priori algorithm using candidate generation, and then mining various kinds of association rules. Of course, we'll go for classification issues, decision trees, and Bayesian classification. This will be your module 2, and then when we go for module 3, you have different type of clustering methods, hierarchical methods, density-based method, outlier analysis, and of course, you will be having spatial data mining, multimedia data mining, text mining, time series mining, and mining the World Wide Web. So these are the things we will cover. So first module will be covered in 12 hours expected, and then module 2 24, and another 24 for module 3, and totally constituting 60 hours of lecture. Okay, so we do not have any practical sessions. Having said this, let us start the lecture. Okay, students, hope the audio and video is clear. If you have any problem with this, you can chat in the chat box. Okay, so I will just check. If it is okay, I will continue, because so far it is very basic things we explained, and now we are going for the subject inside. Okay, introduction of the subject. So that's why I'm asking you, if anybody finding a problem with audio, you should please convey me. Okay. So I'm going for the chat. So is it okay? Is it? Am I audible? Okay. Hope it's so. Okay. So I'm continuing. So the evolution of database technology started in 1960s with the basic data collection, database creation, and IMS and network database management systems. Okay. So I feel before going this, let us go for what is data, what is information, and then we'll come back. Okay. So that will be better, I feel so. So I'm going skipping one step and I will come back. Okay. So everybody know what is data. Okay. So data, when you say, it is an individual unit or a raw material that does not carry any additional meaning or something. So somebody say 5, it's a data. Or somebody say it is 99, it's a data. But when you say in an examination conducted during this period, a student got 95 marks, which means that is called information. Whereas data means 95, so that is 95. So it does not carry any additional meaning or information. That time we call it as data. And when data, when it related with another data, which it conveys an extra meaning or a meaningful data, we call it as information. So that's why data is an individual unit that contains raw material which does not carry any specific meaning. So I have to study one example. Okay. So anything, say a number or a name or whatever it may be. So when it stand alone, it does not have any meaning, but it is correlated or connected, related with any other data, and when both of them are correlated or many are correlated, that time it will give you a better meaning. So that meaningful data, we call it as information. That is, information is a processed, organized data presented in a given context and is useful to humans. Of course, information is a group of data that collectively carry a logical meaning. So, of course, a meaningful data is called information. When you know data and information, you can now think of what exactly is databases. A database means it's a vast collection of information that is or interrelated data. Simply, you can say a database is a collection of large set of interrelated data that is organized so that it can be easily accessed, managed, and updated or even deleted. Okay, so whenever data is organized in such a way that it can be easily accessed, managed, and updated, we call it as databases. Of course, computer databases typically contain aggregations of data records or files containing information about sales transaction, interactions with specific customers, etc. Of course, you all have this idea before itself. So I have just informed you about or recall. No, I try to make you recall this. Okay, so data, information, and database. Data means it's raw information, raw material, which is say a number or a character or whatever it may be. Information means meaningful data. And databases means a collection of interrelated data that can be easily accessed, managed, and updated. So, and of course, database management system, it's a software. Okay, so that manages databases that we will come to in the later stage. Okay. So before that, let us come back. So in 1960s, it started with data collection, database creation, and network databases. All these things started in 1960s. 1970s, you have your relational data model. So relational data model means normally we use. Okay, so that is the tables. So okay, so the table model which we use in SQL, that is a relational data model. Okay, and relational database management system, and of course your Oracle is a relational database management system. And 1980s, relational database management system, advanced data models, so extended relational, object-oriented, deductive, etc. Okay, so object-oriented database management system also we have, and object-based database management system also we can. So an application-oriented database management system, that is spatial, scientific, engineering, all these things. In 1990s, data mining and data warehousing, multimedia databases and web databases started with the advancement of internet technologies. Okay, so the 1990s we started data mining, and 2000, when it comes to 2000, stream data management and data mining and its applications emerged, and of course web technology, XML, data integration, and global information systems. So all these things happened when your internet become very popular, and nowadays it is very much popular, since say for example, whatever you chat in your Facebook, whatever you make writing in your what do you call the applications or in the internet, all are being watched. And of course when you go for a shop, your transactions, your interest, your purchase history, all these things are watched or being applied with data mining to explore knowledge for getting more profit for that particular company. Okay, all your transactions are being assessed, all your Facebook comments can be assessed. So that are all areas the technology which we use for analyzing these things are called data mining, that we will come to know in detail in the forthcoming lectures and of course the slides. So let me go for now database management systems. Okay, so database management system, and of course it's a software. Okay, you are all familiar with Oracle, MySQL, both these database management systems you are familiar with. So this is a software which is used to manage database, is called database management system. Okay, and of course DBMS allows users the following tasks. So we have different tasks. The major task which we can do in a database management system is data definition. And of course data definition means, so you can create, say for example in Oracle you create table name and its properties, all these things you will make it. So that is a data definition. Okay, and of course you can modify the definition, and of course removal of definitions. Okay, so when you create a table itself, you can alter it using alter command. Okay, so these are all data definition. Definition means there is a fundamental difference between the normal data definition and of course data updation. Data definition means you are specifying the table name and its field, its types. So when you change the field type, that is called you are updating the definition, or even you can delete a field from a table. So that's called data definition updation. Okay, so data updation means inside the record you are going to change the data. Okay, say the value is 5, now you have changed it to 5. That's not a matter. Okay, that is data updation. But deleting a field or adding a field, you call it as data definition update. Okay, understood? So it helps in insertion, modification, and deletion of a actual data in the database. So that's called data updation. And of course, data retrieval. Everybody knows. Select star from a table, okay, or select a particular field from a thing. So this is called data retrieval. It helps in retrieval of data from the database, which can be used by applications for various purposes. Say for example, a user, normally database management system is a query based. Okay, so whatever you ask query and it will give you the corresponding data from the database. So that is database management system. So it's only it works on in a query based or a query oriented application software. Okay, and then user administrator, say the database administrator can define different views. He can play with 3 levels of abstraction. When you study database management systems, you may have already studied 3 levels of abstraction. So what are the levels of abstraction? Level 1, that is user level, conceptual level or conceptual or logical level, and then you have physical level. So what do you mean by user level? It is a user which uses the particular software. So he does not have an idea of what tables inside it or how it is being stored. Okay, and when you go for logical data level, what it indicates what data is to be stored, which means if it is a relational database management system, so it will be different actual tables, not the views. The views we will provide only to the users. Understood? So the people who are designing the actual table, so that we call so what data. So that is the thing for logical level. When you go for physical level, so these are the what hashing method we have used for storing. So what method we are using for, or how the data is being stored in the memory, what hashing method, how it is accessed. So all these things will be in the physical level. So a database administrator can control different levels of abstraction. Okay, so for data security and of course monitoring the users, monitoring the performance, maintaining data integrity, dealing with concurrency control and recovering information corrupted by unexpected failure, all these things, a database administrator. Okay, so these are the tasks, important tasks. When somebody asks you what are the important tasks of a database management system, it is simple. What are the things? Data definition, okay, data updation, data retrieval, user administration. Okay, so these are the 4 important use of database management system. And of course, the whole database management system is query oriented. So you ask a query and the database management system will retrieve you the relevant data. Okay. And now, with this perspective, when we go for data warehousing, okay, so data warehouse are, by definition, they are called the central repositories of integrated data from one or more heterogeneous sources, which means that data warehouse means it's a central repository area, so where we store all this data from vast variety of heterogeneous sources, okay, connected through internet. Okay, of course, so different places we try to collect all data and place it in a central place, so that is called data warehouse. Okay, so they store current and historical data in single place that are used for creating analytical reports for workers throughout the enterprise. Okay, so which means that throughout the time we collect the data from all time with respect to a particular time, or not particular time, with respect to a continuous time, we collect data and we make that data as historical data and we store in a particular place, so that every data, all collected data is available in a single place, unlike the other things, say normal database management system. Normal database management system will go for always updates. Say, suppose if we take your banking system or any other type of operational database management systems, you will find this difference. So here data warehouse means what exactly we do is we are collecting all data from different or heterogeneous, that is different type of sources, and collect in a single place. Okay, so that is the major thing. And data warehousing means it's a process of collecting and managing data from varied sources to provide meaningful business insights. Okay, so which means that why we are collecting all this data from different places? So to give additional intelligence to or extract new knowledge, so that it will help the decision making of the particular company. Understand? A company, his sales, his manufacturing, his HR, from all these departments, it collects all information or data and it keeps in a particular place, and then it try to, so why they are keeping all this data in a particular place? For extracting new knowledge by performing data mining. Okay. A data warehouse is typically used to connect and analyze business data from heterogeneous sources. Heterogeneous means dissimilar sources. Okay, so varying sources. Okay, and of course, when you say data warehousing, data warehouse has some characteristics. Okay, so first is subject oriented. Subject oriented means what? Simply application oriented. For what purpose you are doing? Suppose if you are doing for a specific company, all data contained in the particular data warehouse will be regarding only that company. Which means that it is highly subject oriented. Unlike operational database management systems or operational systems, just like I told you, one operational system, banking system, your other systems, the data in the data warehouse revolves around subject of the enterprise. So for what subject you are going to collect this data? So that is very, very important. Subject orientation is not database normalization. So while studying database, you may have studied normalization. So what is normalization? In order to reduce the data dependency, or in order to reduce the redundancy in data, you try to decompose the data so that there will not be any redundant information. So that is not the case. Here we will not do any normalization. Even if the data is already normalized, we will try to denormalize it so that the query will be faster to perform. Instead of searching in different tables, we will try to make it in a same table. Okay, so subject orientation can be really useful for decision making. Of course, according to the subject, when you collect the data, it will help you for essential decision making. Okay, gathering the required objects is called subject oriented. Okay, gathering the required objects for a specific subject is called the subject oriented case. Understand? All data warehouse have a specific purpose or a specific subject for which it is going to be applied. So that is what subject oriented means. Understood? So now it is integrated. How integrated means what? You are trying to intercorrelate it, or trying to make them integrated. So why it is so much needed? Because it is, we get the data from different sources. Understood? We get data from different sources. So that's why this data should be integrated. Okay, so this is the second characteristic of a data warehouse. The data found within the data warehouse is integrated. Since it comes from several operational systems, all inconsistencies must be removed. Say all types of data inconsistencies must be removed. And consistencies include naming, these actually it is inconsistencies include naming conventions, measurement of variables, encoding structures, physical attributes of data, and so forth. Okay, so data must be integrated. So all this data which is collected from different sources or heterogeneous sources must be integrated. So this is the second condition or characteristic. And of course, these data must be time variant, which means that, say a sales, okay, say a sales in a supermarket. Suppose if you want to make a data warehouse of a sales supermarket, so at each time we will have different sales. Understood? So that time that sales amount is varying according to time or according to the customer. Understood? So every time when you collect a data for a data warehouse, it will always conduct, you always have a time field. Okay. So while operation system reflect current values as they support day-to-day operations, data warehouse data represents data over a long time horizon. Okay, say for example up to 10 years. Say for example your data, suppose if you are making a data warehouse for a company, so what you will do, you will collect, say for suppose since inception of that particular company, we will try to gather all information and we will try to keep it in a place. Okay, so and this time also we will maintain as a criteria, which means it stores historical data. Understood? So all historical data will be available in that particular data warehouse. It is mainly meant for data mining and forecasting. So what exactly we try to do is, we try to, when you go for data mining, we use this data warehouse to extract the current knowledge and try to extract new knowledge from this existing data or a past data, and then we try to make a prediction. so that we will get more and more profit in the future. The user needs to look at data on the current and past purchases. So we try to extract the knowledge of past experiences and make that for profit in the future. Okay, and of course this should be non-volatile. So non-volatile, of course, from the beginning when you study computer science, you used to study this. It's okay, volatile memory and non-volatile memory. So which means that non-volatile means your hard disk. Even if whenever the power shut down, it will not go. So whereas if it is volatile, say your RAM, whenever your computer is shut down, whatever data is stored, the RAM already gone. It's okay. So same way, here in the case of data warehouse, once the data is cleaned and stored in the warehouse, that will be permanent. Understand? So that data will not change. Okay, so unlike the normal case in the operational database, suppose somebody withdraws something or somebody make the deposit in a banking operational database, it all will go sudden update. But here, once we make a historical data, that will remain the same, unless otherwise there is a serious issue. Okay, so which means that the updation in a data warehouse which is already been stored, the data which is already been stored, which is very less. The data in the data warehouse is read-only, which means it cannot be updated, created, or deleted unless there is a regulatory or statutory obligation to do so. Understood? Say once we make a sale, okay, so once we make the billing, unless otherwise there is some problem, that will not change. So that's why once we put it in the data warehouse within a particular time, it will remain. So recall that what are the characteristics of a data warehouse? Easily four characteristics. What are they? The first one is simply subject oriented. Should be so for a specific purpose you are going to design the warehouse, data warehouse, so that it will have the particular purpose. For that purpose, essential data being collected. Understood? Then the data which is extracted and stored will be integrated, which means that data from different sources will be integrated. Okay, and then the data which is already stored are time variant data. Okay, depending upon the time, it varies. Okay, so which means that you are going to store historical data. Okay, and then next one is non-volatile, which means the data once is stored is read-only and it will not be updated. So this four is very important. Okay, namely subject-oriented, then integrated, time variant, and non-volatile. Okay, clear? So these are the characteristics of a data warehouse. So these are all introduction. When we go inside, you will know what exactly are these properties or characteristics. Now let us compare what are the basic difference between database and data warehouse. So normal database management system you may have already studied, okay, and now it is a time for how data warehouse is much more powerful than normal database. Okay, and that is what we are going to study. So, okay, so the first is processing method. The normal database management system online transactions, we call it as online transaction process. Okay, so this is what we do in a operational database, such as your banking system or your railway reservation system or any reservation system. So whatever it is performing in a online processing or online booking or online purchase. So whatever you are doing, that we call it as operational database. Okay, so that's online transaction processing, normal database management system. Okay, but in the case of data warehouse, it is online analytical processing, which means what? In the case of data warehouse, you have stored the historical data you have collected, cleaned, and integrated all the historical data and it is in one place. And now what you are going to do is you are going to analyze this historical data for decision making or for making more profit for a company or an enterprise for the future. Understood? You are trying to learn from your experience and then you are going to apply for it in the future. So this is what online analytical processing means. Clear? So now let us go for optimization. Okay. So when it go for optimization, database management system does deletions, insertion, replacing, updates, large number of short online transactions quickly. Understood? So it works in very fast manner. And normally for an operational database management system, it will be in a hierarchical stage. Okay, hierarchical type of storage. Okay. Rapidly, but in the case of data warehouse, everything is available in a particular site. Unlike normal database management system, in the case of data warehousing, all data is available at a particular place. Now, what you need to do? You have to process rapidly, analyze the massive volume of data and provide different viewpoints of analysis. Understood? You have to, your problem is to analyze the data. There, in the case of database management system, there is no analysis or something. Say, for example, if somebody is going to the bank to withdraw some money, get the report and then update it in the database management system. So it's only a query-based processing. But here, the question is, you have to create different viewpoints for different analysis from the existing data. Understood? So this is the fundamental difference between data warehousing and database management system. But then when we go for the data structures involved in database and data warehouse, you will find huge changes. So here, highly normalized data structure with many different tables containing no redundant data. At least third normal form, the data will be in the third normal form. Okay. Even if you didn't go for fifth or inner, or no, fourth or fifth. Okay. But it will be highly normalized. But in the case of data warehouse, you will only have denormalized data structures with few tables containing repeated data. Here we are not bothered about any repetitions in the table. Okay. But in the case of database management system, we always try to reduce the redundant data. Here, we only worried about, in the case of data warehouse, we only worried about data missing. Duplication is not a problem. Okay. So whenever we want to analyze the data, it should be available. This is a condition for data warehouse, whereas for the other thing, duplicated or redundant data is not at all allowed. Okay. One more problem is there. Here, data updating doesn't happen or even very rarely happen. So repeated data also will have data consistency will be there. But in the case of operational database management system, it's sudden changes. So whenever it is there, you do not have any multiple copies. If there is multiple copies, the data updation will happen very slowly. Okay, so that is called data inconsistency. So here data inconsistency will not be there because there is no updates. It is only a read only. Okay, thus data is more accurate but slow to retrieve. Okay, understood. Data is more accurate but slow to retrieve. Why it is slow to retrieve? Because it is available in different tables, and that tables also may be in a distributed database management system, which needs to access servers of from different places, which means it will be slow to retrieve. Okay, since an information, in order to gather an information, we need to go through different tables, and that tables may be stored in different site. But in the case of data warehouse, everything is available at a single point. That we call it as data warehouse. Thus, data is potentially less accurate but fast to retrieve. Okay, so when you go to data timeline, current real-time data for one part of the business. So this is one thing. Historical data here, it is very good for all parts of the business. So for analyzing the business, here we use historical data, but in the case of database management system, it's widely used for online transactions. Data analysis. Okay, analysis is slow and painful due to large number of table joins needed and the small time frame of data available. Okay, why we need joining of many tables? Because in order to maintain in order to avoid data inconsistency or due to redundancy, what we do is, in the case of database management system, we apply normalization. When you apply normalization, what do? You split into different tables so that there will not be any repetitions, understood, or redundant data. Okay, so that is why when you want to analyze this, you have to perform that denormalization once again. So it will take join to perform join after join in for the different tables. So that will take too much time if you take normal database management system for data mining or data analysis. Okay, and of course storage is limited. Okay, so here limited to a single data source from a particular business function. Okay, so it is for a business function, it is very much less. But for the other thing, all relevant data, whether it is redundant or whether it is any other inconsistency, even if it is redundant, we try to collect all data to a particular source. Okay, and it will be a massive. We need massive storage for this. But in the case of database management system, we does not need much massive storage. And query type, normal query, simple transactional query. So create, update, or even retrieve. So that kind of queries are in normal database management system. But here it is complex queries for in-depth analysis. Say for example, the queries will be like which product in association with an n number of products, if we purchase in next year with this much amount of volume, we will have more profit. Understood? So this is a business query. Understood? This only we need to answer using analysis. Two types of query. One is update or subtract or add. Okay, so something like it will go for normal database management system, or a delete. Okay, or a normal update. But in the case of data warehouse, it has to face queries like, okay, what changes in our when we do in our strategy, our profit will be increased. These kind of queries will be, we are asking for data warehouse. So this is a fundamental difference between data warehouse and database. And data summary, highly granular and precise and clear also, of course. If you ask something, it will give you very clear answer. Say for example, I am checking my balance in my account. It will give you the exact amount. Clear? But in the case of when you ask, so what strategies if I make next year, my profit will be more. So if you ask such a query, of course it will be little fuzzy. The answer will be little fuzzy. If you these conditions are come to know, if some conditions, specific conditions are true, and then if you apply these kind of business strategies, you can achieve better profit. Something like it will be as granular and precise as you want it to be. Okay, so that will be data warehouse. And now let us continue. Okay, so when you go for the operations of normal database management system, or even okay, it will be mostly updates. Say for example, somebody withdraws an amount, so automatically it will update in the bank account field. But in the case of warehouse, it will be reading. Okay, so why it reads? For analysis only. It is not, it will not update the data, because the data, once it is stored in the warehouse, it is a historical data that you use for predicting new things in the future. Okay. And of course, it is many small transactions. In standard database management system, you apply many small transactions. Okay, but in the case of data warehouse, the queries are long and very complex. I told you a query. Okay, so it is very complex. And of course, here it is MB, GB of data only. It will be normal database management system will be having. But in the case of data warehouse, it will be having huge amount of data in constituting in GB to terabyte of data. Okay, and of course, in the case of standard database management system, it will be the current snapshot. So, for example, my balance, what is it current? So that only it will be happening. But in the case of data warehouse, I will store the history. Understood? For new predictions in the future. And of course, here we use loads of indexing and hashing scheme for faster retrieval. But okay, lots of here what we do, the disk will scan it because it is a huge amount of data. Here it will be raw data, but in the case of data warehouse, it will be a summarized and of course reconciled data. Okay, and here of course now for a normal database management system, it will be huge number of users, but in the case of data warehouse, very less number of users. So those who are the business analysts, analysts, or even decision making people, or even high level management people, okay, they only will be interested in data warehousing and data mining. Understood? Clear? Here in the case of data warehouse, the data being stored in a particular single place or a centralized place for analysis. Okay, for analyzing for what? Future profit, future benefit, or something else. Understood? So this is a fundamental difference between normal database management system and normal data warehouse. So now let us go for data warehousing framework. Okay. In the case of data warehousing framework, so what you do is, first step is, I told you, from heterogeneous locations or heterogeneous type of data, you try to collect to a place. Understood? So this is what you need to do. Okay. So suppose in this figure, this is a figure taken from your textbook. Okay. Okay. So syllabus will be uploaded in what you call your Google Classroom. Okay, and you can download it. Okay. By this way. So what you do in the case of data warehousing, the first step is to get data or from different sources, and this data will be highly heterogeneous, which means it will not be similar data. Okay, understood? And then when it comes to dissimilar type of data, what do you need to do? You have to perform 5 tasks. Understood? First is, whenever you receive a data from a data source, you have to clean it and you have to integrate that particular data with the data which you gather from other sources. And of course, you have to apply different transformations. Say, suppose if you receive data from an operational database management system, what do you have to do? You need to denormalize. Understood? So for faster query process. And of course, you have to load and you have to refresh. So all these processes you will do for as the pre-processing to store the data in the data warehouse. Okay, warehouse. This process is called data warehouse. Once you have stored this data by cleaning, integrating, transforming, loading, and refreshing, this data will be asked by query and analysis tools. Okay, and then it will take this data, and then your data mining systems will analyze this data, and then it will give its prediction to the particular client. The client normally will be the higher management people or even the decision makers of the particular firm or company. Okay, so this is the architecture. So understood? First thing is to collect data from different heterogeneous sources, clean it, integrate, transform, load, and refresh. We will study all these terms: cleaning, data integration, transform, loading, refreshing in the forthcoming chapters. or modules, and then that time you will be clear about. And then once you perform all these operations, you store this data in a single place. You are collecting data from different locations, different types of data, and then you are going to store it in a one place called data warehouse. Okay, and then all data available in a single place, that will be asked by data mining or data online analytical processing type of queries, softwares, to get this data and then make their intelligence processing, and then make the conclusion for prediction, classification, all these things. Okay, and this data will be accessed by its clients. Like it can be a company top level management, it can be the analyst, or even the decision makers of the particular firm. Okay. So this is the architecture. This is very important. Okay, easy, but when you go for data mining, so far we have studied about only data mining. Okay, so data mining we have discussed. Okay, in the case of data mining, one second. So now let us go for data mining. So far we have studied about only data warehousing. We have given the introduction of data warehousing. So now let us go for data mining. Data mining means, is also called knowledge discovery, which means what? We have historical data in the data warehouse. Using special processing called data mining, we have to discover knowledge. So that knowledge will be used for predicting, or even what you call or making strategies or making decisions for the future. Okay, understood. So that is what data mining means. It is a process of extracting interesting. Okay, interesting means it can be non-trivial. Okay, without any uncertainty, implicit, previously unknown, and potentially useful patterns for knowledge from huge amount of data stored at data warehouse. Understood? So from data warehouse, what exactly you should do? You should extract that new knowledge using that historical data stored in the data warehouse. You have to process it to provide new knowledge for the particular company, firm, or organization, so that it will be very helpful for them to make future decisions or future profitable decisions. So that is what data mining means. It have many alternative names. One is called knowledge discovery, which is also called mining in databases. Okay, so that's called KDD process, knowledge discovery process. Okay, so that's knowledge discovery in databases is called KDD process. And then knowledge extraction, data or pattern analysis, data archaeology, data dredging, information harvesting, business intelligence, etc. It has huge applications in financial application, financial analysis. Say, for example, your stock market data. Say, take Nifty or what do you call your Sensex. Okay, so what will happen? Every time you have suppose if you make a what do you call the stock value of a particular company, okay, or a mutual fund performance. Okay, so what it have, according to time, it have different returns. So, and what are the data associated with it? It has a, say, if it is a mutual fund, it has a fund manager. Understood? If you are directly going for stocks, a company have it management people. Okay, each management personnel have different behaviors. So what we try to do in financial analysis is, if it is for a stock, if these people are in the top positions of a particular company, and this kind of situation comes, we try to predict their behavior, so that we as a, as an investor, what we can do, say, according to their behavior, if they do this, if we try to predict their behavior, so that we are going to analyze the performance of their stocks in the financial market in a particular situation. Say, for example, COVID-19. In March, so many companies fell down. Okay, so understood. And that kind of situations we try to predict using historic data. Understood. And of course, we try to analyze the behavior of different fund managers, in the case of mutual funds, different company higher authorities. So all these things we do in financial analysis for predicting future markets. Understood? Financial markets, like say Nifty or Sensex or whatever. And next is telecommunication. Telecommunication means it's industry, which means your internet things and other things. What you do is you have huge amount of data being transferred here and there. So you can use that particular data for the benefit of a particular company. This is what I'm telling. Say, for example, you are writing something, your opinions, everything can be gathered by, say, Facebook or Twitter, all these things. Say your behavior, your attitude, your taste, all these information can be mined for marketing or even predicting the political changes, all these things. Understood? And then intrusion detection, so which is nothing but a classification. Say what you do is you have a specific group, okay, or a WhatsApp group or something. So you are trying to store the historical data of that particular group. Imagine that this group is very much what you call secure type of group. Okay, so everybody's behavior you try to analyze by their chatting, smiley, whatever, or whatever it may be. So you try to analyze the behavior, or even the abnormal behavior you try to identify using mining rules. Understood? So that area we can use it for intrusion detection. Then of course retail industry. Say for example, suppose you have you can take Reliance Market or any supermarket. So what they do is they try to store their historic data in a data warehouse, and they try to analyze, so which product next year, if I invest more, I can sell it more. Understood? Say for example, they try to get interesting patterns. Say for example, when you go to a supermarket, you can see that some chocolates or very attractive things, it will be kept very near to the cashier. Understood? This is a strategy evolved from past experience. So that time what will happen? If children comes with the parent has to wait in the queue, right? Normally what will happen? These children, they will be restless, and of course the parent he cannot run here and there, he has to be in the queue. So that time the children will be attracted. So that's why they keep very pleasing things for the children very near to the cashier place. So, okay, so that the children will be will get attracted, and of course they will compel the parent, and of course the parent cannot run here and there because he is caught up in between with different people, so he cannot do anything. So that kind of strategy they try to evolve using data mining. Understood? Of course, higher education strategies. Higher education, say for example, the historical data of placements can be and teaching levels can be used for future strategies for training next generation students. Understood? So these kind of things we can do it with data mining. When you go for energy industry, and of course you have to be very, say, you have loads of data, you have sales team, you have of course you have energy creation teams, and of course you have laborers. All this data you try to integrate it to make new knowledge so that your industry will be more profitable. And of course spatial data mining, which means your images, smileys, all these things will come in spatial data that we'll discuss later. And of course biological data analysis, you can other scientific applications, and you have manufacturing industries and engineering, all these things. So criminal investigation, and of course you try to make according to a criminal's behavior, you try to analyze his criminal background, all these things. Okay, so you can mine these things using data mining, and you can make criminal investigations. And of course counter-terrorism. So this is very, very important. Say for example, so suppose some group have attacked a city in a country. So in our country, say Bombay. Okay, Bombay, some terrorist has attacked. Okay, so now the attack is already happened, so we couldn't do anything. So now what we do is, suppose Mumbai is being attacked. Okay, so now next is how much probability or how much strength that the same or it associated terrorist groups will have an attack on Chennai or Kolkata. This is what we are going to analyze. Okay, so we have find out an attack, and say for example their attack was, say it was like a bomb blast. Okay, and suicidal bomb blast. So which means that how much probability that Coimbatore is also being attacked by the same troop or associated troop, or what will be their strategies. Okay, so how they will do, where, which are all places their associates are there. All these information we can mine about. Understood? So that is how we can prohibit or even counter terrorism. We can do counter terrorism. Understood? Clear? So these are some of the applications. So whichever thing you go, there are all you can find that data mining applications. So now data mining versus online analytical process. Okay, so this is data mining and analytical process. So analytical process I already didn't discuss. Okay, so it is almost same, but let us see what are the differences. So in the case of data mining, we use multi-dimensional analysis. Multi-dimensional analysis means what? Say for example, seeing a person from seeing a problem from different dimensions. Say for example, say an examination. Okay, examination can be viewed in different views. One can be from a teacher's perspective. Another perspective is student perspective. Another one is, say, the management perspective. Another one is the parents perspective. So which means that here in the same way, in the case of data mining, we try or attempt to analyze data in a multi-dimensional views. Understood? So that's what we try to do with data mining. Okay, but in the case of online analytical processing, it's online analytical processing it does. It has huge number of dimensions. It has limited number of dimensions in the case of online analytical processing. Okay, data mining deals with the summary of data. Understood? Data mining, it will give you a summary of analysis. But in the case of online analytical processing, deals with the detailed transaction level data analysis. Okay, it will give a detailed transaction level data analysis. Okay, so it is an insight and so it will give you an insight and prediction. Okay, but in the case of here it will be an analysis. Okay, It is used to predict the future. Okay, data mining we use for predicting the future, but it is used for analyzing the past. Okay, so here we analyze the past, but mining, what we do, we extract interesting patterns for future profit. So that's data mining. So here it is a bottom up, the other one is a top down approach. Okay, discovery driven, and of course it is query driven, and it is emerging technique, and of course this is OLAP is widely used. Okay, so now let us go for the knowledge discovery process, the entire data mining or knowledge discovery process, or even the steps involved in discovering the knowledge. This is what we are going to study. So now the same way in the case of data warehouse, we saw the data will come from different places. Okay, so that data need to be cleaned, transformed, and of course you have to refresh, you have to do all type of pre-processing work, and then the data should be integrated. Okay, that comes from different sources, and you have to store it in the data warehouse. Understood? Clear? And then what you need to do, once it is stored in the data warehouse, what you need to do is you extract. You need not want the entire data. You need data for performing your tasks or performing your, what you call, your decision. Whatever data which help you for making a particular decision, that only will take from it. Okay, so that's why we need to have a selection here. So we select the relevant data from the data warehouse. Here the major advantage is we need not go here and there. Understood? All this data being collected and placed in a single place or a centralized place. So which means you need not go here and there. You can get all this available data from here. From that, the most important data you collect and you try to make the task relevant data. So that is what it is called your selection. And then once the relevant data is collected, you apply data mining algorithms. So normally it will be a rule-based system. So you try to make some rule-based analysis, and then what you try to do is you try to extract interesting pattern. Understood? That is what a data mining means. And then once you have extracted interesting patterns, you try to make an evaluation. Okay, and then you extract the knowledge from it. So that's what the entire data mining process or knowledge discovery process. Okay, in database process. Understood? Once you extract the knowledge, you also will have to report it. For reporting it, what you do is you use proper visualization tools. Okay, so that is very, very important. So the data visualization is very, very important in the case of data mining to make people understand things very easily. So that's why. So what are the steps involved? You collect data from heterogeneous sources, make all pre-processing, including data cleaning, transforming, or refreshing, updating, all integrating, all these things you do, and then you make the data warehouse, and then when a task comes, what do? You extract only the relevant data for that particular task. Okay, that's called your data selection. And once you selected the particular data, what do? You perform data mining. So data mining means you will try to apply mining algorithms or rules so that you will extract interesting patterns from a rough data, huge data from that, and then that pattern will be went for evaluation, and then it will be used for reporting using some reporting in terms of visualization and other things, and then the knowledge is explored. So these are the steps involved in data mining. Understood? Knowledge discovery process. Clear? So this is a architecture, and of course you will find some feedbacks. So whenever there is some update comes, it has a feedback source. So this is what available in your book. It is the same thing. Okay, so the same thing. But since this picture was not clear, so I used that. You can use this picture also when the question comes as data mining, knowledge discovery process. Okay, clear? So now this is same thing. So the same database, you extract data, you do all the process like pre-processing, you make it in the data warehouse. This is the flat files. So now you make the selection and transformation process, okay, and then you apply data mining and then evaluation and presentation. So that's why the presentation is very important. So reporting. So you can, after data mining, what do you get? Interesting patterns. So that interesting patterns, that predictions. So what you try to do? You present it using some data visualization tools. So which means that this is similar to a knowledge mining. Say for example, suppose if you go for gold mining, what will happen? It is not that it is much difficult to get the gold as such. So it will be mixed with many other things. So, and of course, if you say for example, if you mine for gold, imagine that maybe 1,000 kilogram will give you 2 grams of gold, which means whatever data or things are available in this database, data warehouse, maybe some 90% of things are irrelevant. What do you need to do? You have to mine in a particular way that you extract that remaining or your relevant data, and then using that relevant data, you have to make prediction so that you will get more profit in the future. Okay, so this is what is meant. Okay. Okay. So I feel we will make all these steps today, okay, and then we will stop today, okay, and you can ask doubt for it, okay, and then now for first 3 minutes I try to conclude what I was trying to teach you from the beginning, and then last 5 minutes I will give you for doubts. Okay. So while doing data mining, we have roughly set these terms. Data cleaning. Data cleaning means it is to remove noise, okay, and inconsistent data. Okay, that is remove noise. Noise means what? In the case of signal processing or image processing, noise means unwanted signal. Okay, but in the case of data sciences, removing noise means removing unwanted data. Understood? So that's removing unwanted data, and of course inconsistent data. Data, say, from, suppose if you get data in a different say for example, age of a particular person. One, the data collected from one server, it says 26, another says it is 46, which means that there is huge inconsistency in the data of a particular person. So that kind of data we need to clean it. There should not be any inconsistency in the particular data. So that's what we do it in the data clean. And then data integration. Data integration means what? We are getting data from different number of servers or sources. So that we need to integrate. Understood? So where multiple data sources may be combined. So that is very, very important. And then data selection, which means what? You have 90% of your data are maybe irrelevant for a particular task. In your 90% of the data in the data warehouse may not be, maybe irrelevant. But what you need to do? You have to select that relevant data for analysis tasks. Okay, that is where data relevant to the analysis tasks are retrieved from the data warehouse. So that's called data selection. And then data transformation. And the incoming data may be in a different format. Understood? And that data you try to make it in a new format so that it will be easy for your data mining algorithm. So that's what you transform the data in such a way that the transformed data will be much useful for the your what do you call data mining algorithm. So where data are transformed and consolidated into forms appropriate for mining algorithms by performing summary or aggregation operations. So this is what we mean by data transformation. And data mining. So what data mining means? It's an essential process where intelligent methods are applied to extract data patterns or knowledge. Understood? So this is what we call it as data mining. So now pattern evaluation. Okay, pattern evaluation means what? We have extracted the interesting patterns. Okay, and now what do you need to do? We have extracted the patterns, and now what do you need to do? To identify the truly interesting pattern representing knowledge based on interestingness measures. We have extracted interesting patterns. From among that, the most important interesting patterns you need to make it. You make an evaluation for them. And finally, these interesting patterns in terms of new knowledge should be made to a presentation. So knowledge presentation, where visualization and knowledge representation techniques are used to present the mind knowledge to users. Okay? So this is what we need to do. So tomorrow we'll go for with an example for this. So today we'll stop there. Okay, so that is data mining in business intelligence, and we have many other. So need, and then only we will go for the syllabus. Okay, so let me for 2-3 minutes. Let me give you what exactly I have given today. So I have given you evolution of database technology. This is just what you call blah 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 blah. You can have a simple note of these things. Okay, and then I told you data. What is data? Data is very raw material. Okay, but in the case of information, what exactly is? It is meaningful data. And database means it's a collection of interrelated, meaningful data which can be easily accessed, managed, and updated. So this is what I said. And then database management system. I told you it's a software that is used for managing database, and the major characteristics of tasks it has to are data definition, data updation, data retrieval, and user administration. These are the things you should know about database management system. For this, data warehousing means what? It's a central place where we collect all data and stores. So that place we call it that entire data collected and stored in one place, that we call it as data warehouse. Okay, data warehousing means what? The process of collecting and managing data from varied sources, that we call it as data warehouse. So data warehousing means it's a process. Data warehouse means it's a place. Understood? And we studied the characteristics. The first one is subject oriented. Say for example, if you try to create a data warehouse, it should have a specific purpose, and that purpose centric it will be. That is why it is called the subject centric or subject oriented. Then this data available in the data warehouse are integrated. So which means that it has been collected from different places. So it has to be integrated and it should avoid all the mismatches, all these things. And then it has to make a compromise at least when mismatches comes. And then it is a time variant data. So which means we are going to store a historic data in the thing. And then it is a non-volatile. Non-volatile means it is permanent. It is read-only. Understood? It does not undergo any update. Understood? So it does not make any changes. So just like your hard disk. So the same concept here. So these four are very, very important. And then I told you difference between normal database management system and data warehouse. The fundamental difference is here it is a highly query based. We already have something in the database. We ask something, it will retrieve something, or we tell something to update, that will update. So this is normal database management system. But in the case of data warehousing, things are very different. Here, what we need to do, we use data mining techniques or online analytical processing techniques to extract new knowledge from the historical data. So this is a fundamental difference I told you. And then Here it is mostly updates, and here it is reader, no, and of course the storage will be more. And this is a framework which we store, which we discussed, which means that we have different sources. We do all this pre-processing, that is cleaning, integration, transform, loading, refreshing to make the data warehouse, and then data mining tools, softwares or data mining algorithms will access this data for extracting new knowledge. And then we went for data mining, which is called knowledge discovery from data. And then it has data mining means it is a process of extracting interesting patterns or patterns or knowledge from huge amount of data. It has many other names, including the KDD is very, very important. And of course, it has many applications. I mentioned some of them. And then we studied the difference between data mining and online analytical processing. That also we studied. And then the architecture of this, the entire process or data mining process we discussed with its different steps. So this is in your book. Please follow this, okay? And that step we discussed, and we concluded the lecture for today, okay? So now it's your turn to ask if you have any doubts in the chat box. Okay. We can have chat. Can you hear me? If you have any queries, you can ask me now. Okay. It's okay.